To wrap up this section, and it's actually going to wrap up what we're going to do in chapter 6, we have some properties of order relationships between rational numbers. Those are our fractions. So we're dealing with here less thans and greater thans. And we have the transitive property. That's if A is less than B and B is less than C, then A is less than C. It also holds true for fractions. The addition property says that if one fraction is less than another, you can add the same amount to both fractions, and that first one's still going to be less than the second. Multiplication property, same thing, but with multiplication. And then you have the trichotomy property, which says that if you have two numbers, two fractions, one of three things will be true. Either the two fractions will be equal, one of them will be less than the other, or it will be greater than the other. And that should be very common sense to you all. What I want to focus on here, and we're going to do an example with this, is the density property of rational numbers. It's the idea of there being an infinite number of fractions, even between something like 0 and 1. There is an infinite number of fractions because of this density property. And it says between any two fractions, you can always find a fraction between them. It's the idea that you can keep cutting things in half and cutting them in half and cutting them in half. I have a couple different ways that you could work these problems in my written notes, but I'm going to go over a real straightforward way here with the video. If you're given a pair of fractions, really easy way to find a fraction between them is to find a common denominator. So our first pair of fractions, 4/9 and 6/11. The common denominator is going to be 99. So the first fraction becomes 44 over 99. Oops. Multiplying top and bottom by 11. Second fraction, if we multiply top and bottom by 9, we get 54 over 99. So what's between them? 45 over 99, 46 over 99, and so on. Very straightforward way to find a fraction between two given ones. So our second pair of numbers here, 14 over 23 and 7/12. Might need a calculator for this one, but the common denominator is going to be 276. That's 23 times 12. So the first fraction, if you multiply top and bottom by 12, you're going to end up with 168 over 276. And I used a calculator for this. I'm not doing this in my head. Second fraction, if you multiply top and bottom by 23, you end up with 161 over 276. So to find a fraction between them, 167 over 276, 166 over 276, and so on. Part C, it's 1/9 and 1/10. Common denominator here is 90, so we have 10 over 90, and then 9 over 90. So in this case, you might go, oh, well, what do we do? Easy way to deal with this. I mean, you could go 9.5 out of 90, but that's not a rational number. What you can do is just double each fraction. And what I mean by that is multiply top and bottom. So we're not really doubling it, but multiply top and bottom by 2. So we would have 20 over 180 and 18 over 180. So what's between them? 19 over 180. The last one, this one, common denominator is going to be really large because you're going to take 568 times 737. But if you find your common denominator here, the first fraction becomes 103,917 over 418,616. Second fraction, again, finding the common denominator, we have 103,944 over that same denominator. So in this case, again, you've got quite a few options here, but 103,930 over the denominator would be one fraction between them, and you've got quite a few options. Like I said, I have a couple other ways that you could approach this in my written notes. If you have any questions about those methods or about what you've seen here, please feel free to reach out.